So I'll be out for one more day. I wanted to pass along another lesson to you. Want to talk to you today about solving logarithmic equations. You may recall that we've already talked about solving exponential equations where we use logarithms. So like for example, if I had 3 times 2 to the x minus 1 plus 4 equals 17, we would solve this by isolating the base and power. 3 times 2 to the x minus 1 equals 13. Subtract 4 from both sides. 2 to the x minus 1 power equals 13 thirds. Dividing both sides by 3. Log base 2 of 13 thirds equals x minus 1. So now if we just add 1 to both sides, we have log base 2 of 13 thirds plus 1 equals x. And that's the exact solution. We could grab our calculator and get the approximate solution. Those are called exponential equations. Today's lesson is the reverse of that, solving equations that already have logarithms in them. Okay, so there are two types of logarithmic equations. The first type is sometimes you will see logarithm equals logarithm, and these are the really easy types of logarithmic equations to solve. So like for example, you could see something like log base 5 of 3x minus 1 equals log base 5 of 2x plus 7. Log equals log. Well, whenever you see a log equals log type of equation, all you have to do is use the following property of equality. And I think that this makes logical sense if you'll just think about it for just a second. It says this: if log base b of x equals log base b of y, then it is logical that x must equal y. In other words, you just kind of disregard the logarithms if they have the same base. So if I have log base 5 of 3x minus 1 equals log base 5 of 2x plus 7, then by that property of equality, 3x minus 1 must equal 2x plus 7. So if I subtract 2x from both sides, we have x minus 1 equals 7. Add 1 to both sides, x equals 8. Doesn't get much simpler than that. So let's think about one more example. What if I had something like log base 18 of 18 minus 2x is equal to log base 18 of the quantity x squared plus 5x. Well, because the logarithms are equal with the same base, just like the previous problem, we can drop them and just say, well, 18 minus 2x must equal x squared plus 5x. This is a quadratic equation, and it would be preferable if it could be solved by factoring, but perhaps quadratic formula would be needed. Let's see, I think I need to put it in standard form by moving everything from one side to the other so that it's 0 equals x squared. I think if I add 2x to both sides, I have plus 7x. And then if I subtract that 18 over, it would be minus 18 equals 0. Oh, well that does solve by factoring. 0 equals x plus 9 times x minus 2. I expect you to still know how to factor the quadratic expressions. We're looking for factors of negative 18 that have a sum of 7, and of course that is positive 9 and negative 2. Now, to finish solving, x plus 9 equals 0, x minus 2 equals 0, x equals negative 9, x equals 2. We have two solutions. So these are your two examples of the type of equations where log equals log. You just kind of drop the logs. You're not canceling them, you're just dropping them, disregarding them. Now, for the second and final part of this lesson, the second type of logarithmic equation you would see is log not equal to log. For example, let's say that we see something like 3 times log base 3 of the quantity x minus 6 minus 5 equals negative 2. So you'll see that this right side, there is no logarithm. So you don't solve it the same way you did the previous set. What you want to do is, step 1, isolate the logarithm and its quantity. So then that says I need to add 5 to both sides. So now I have 3 log base 3 of x minus 6 equals 3. I still don't have the log isolated, so I divide both sides by 3. And now I have log base 3 of x minus 6 equals 1. Now I have the log isolated. So I move on to step 2. Change to the equivalent exponential type equation. Wouldn't this change to 3 to the first power equals x minus 6? So if I evaluate 3 to the first power, that's 3 equals x minus 6. And if I add 6 to both sides, x equals 9. So that's how you solve logarithmic equations where there are not two logs on both sides, there's just one logarithm. So all you do is isolate that logarithm, change to its equivalent exponential form, and everything just solves. Okay, so after you take these notes, make sure that you get the handout and complete that, and I'll see you guys tomorrow.